Hello everybody, today we are tackling day 21 of Advent of Code 2024 and it's Keypad Conundrum. And I have to preface that this problem is very complex and I had to think through it and already have an inkling on how will I solve it, but I will have to write the code as well, so that's going to be interesting and we will have to see if it actually works out. So this problem has us enter a code into a keypad. It's a numeric keypad where you have 7, 8, 9, 4, 5, 6, 1, 2, 3, 0A, where the A is an accept button, kind of enter button, and this would be easy just to enter the numbers. But the problem is that there is a robot that needs to enter those numbers, and we have to move its hand around the keypad so that it can enter the code. And to make things even more complicated, there is another robot that is controlling this robot on a directional pad where you have the arrows and the accept button, which makes the other robot press the key where it's actually located currently. And there is another robot that's controlling this directional one. And then there is us, where we have also a directional pad. So it works in the way that we press a button which controls another robot, which controls another robot, which controls finally the numeric robot. So there are basically multiple layers of robots, and we enter this huge sequence of key presses, which controls the second robot, which controls the first robot, which controls the second robot, which finally controls the robot that enters the numbers on the keypad. So super complicated stuff, especially to think about how those things all come together. And our input is basically a sequence of codes that we need to enter on the numeric keypad. And we need to figure out what's the shortest possible sequence that we can enter so that the final robot enters that sequence on the numeric keypad. So we need to find out what's the length of the shortest sequence and then multiply it with the numeric part of the code on the input. So basically we now multiply the length that we calculate with the numeric part and sum all those together to get the final product. So let's try to figure this out. So let me get the puzzle input, and we now will try to find a proper solution for this. So the thing is that this problem has kind of multiple layers, and I prepared some notes so I know what I want to do here. So we need to first. So my solution, the solution I have in mind is that we would first figure out what's the shortest distance. What are all the shortest paths between all pairs of keys on any of the keypads. So first between all the keys on the numeric keypad, and then between all the keys on the directional keypad. And the reason we need to take all the different shortest paths is that two different shortest paths can have a different that can cause a different shortest sequence on the upper layers. So basically when we have this, it's different than this, because when we press this same key twice in a succession, we just can press twice a button on the upper layer. But if we have to move some from this key to this key, we have to first do some movement on the upper layer and then press A, and then move back to this one and then press A. So it depends really on what is the order of the characters, because every order will have a different result on the layers above. So we can now we can now try to solve this. So I will have grid for the numeric keypad. This numeric keypad will be something like this, yes, but not completely. So it will be this numeric keypad that we have here. So 789 4056 789 456 1 2 3, and then have the lowest layer. And the important thing is that here we will put a hashtag which will tell us that this location is not allowed. Basically, the robots always have to move within the grid, and they never can enter this area when they move the hand. So if they enter this area, it would break the robot. So we have to avoid these empty spaces on the grid. So given that, we now have the numeric keypad, and we also have car directional keypad, which will be character of well, not this definitely. So it's gonna be something like there's hashtag, right? And there was the up arrow, A, and then these, right? So this is the directional one. Yes, so that matches the description. And now what I will initially do is to find the shortest path. So private so we'll have a private dictionary which will have from car to and string, shortest sequences. So this dictionary will store the shortest sequences of key presses that are needed to transition from a character on the keypad to another character on the keypad. So it's gonna be 7 to a. I mean, we can technically put both in the same. So shortest sequence from a character on a keypad to another character on a keypad, given so it will store all the shortest sequences of key presses that allow us to press the target button. So we start on a position that's marked by this character, and we want to move and press this character. So those are the shortest sequences of directional key presses that are needed to get it there. And in case of numeric keypad, we'll be moving in some way through the numeric keys, but we will still have a directional commands to get there. So void cache all shortest sequences. So this method will cache all the shortest sequences, and I will have cache all shortest sequences for a keypad, and we will do this for both. So cache for numeric, and we will cache it for directional. And now for each character in keypad, I will do for each other character in keypad, and we'll cache shortest sequence there. So cache shortest sequence from to on the keypad. So character keypad. So now we now have this method that will cache the sequences, but this is interesting, that suggestion from Copilot, because if we are already on the same character, we can just press it by pressing A once. So if we're already on the character that we want to press, we just press the A button once. So to do that, we can solve it by shortest sequences of character to other character. We'll just put in, let's store that in this way, read-only string, or rather, yeah, so like this, a sequence, a only sequence. So this will be, we can reuse the same instance because all of them will be the same. So actually this is better. So a only sequence, and we will set it here. So this same instance can be used for all the shortest sequences between the same character to the same character. Will be just pressing A. And for the for different characters, we will have to first find the character in the keypad. So we'll do something like that. So we'll go through all the rows on the keypad and all the columns, and we'll find the position of the character. So from point to point, and we'll now want to find the shortest paths. And the shortest paths will have the same length, all of them, because when you move between this character and this character, you know that you have to move once in the x coordinate and 2 times in the y coordinate, but you can do once, or 2 times once, or once, 2 times, and so on. So it's just a different mix of the same characters. So we can do something like shortest path length, and there's gonna be math apps from point x minus 2 point x this way. So this is the length of the path, and we can try to find all the paths from the from point, and just see if they end up in 2 point in the point. So in the shortest path length steps. So it's going to be point in the steps, and so q, and do this enqueuing. So enqueue the from point initially, and while q empty, or rather we would like to store the sequence. So string sequence, store the sequence itself. So initial sequence will be 0, will empty. So while q count is greater than 0, we will state, so rather, actually we can do that PowerPoint sequence, and then do, so if we're on the point, or if sequence length, so if we got to the point, to the final point, we store the shortest sequence. If sequence length is greater than what we're looking for, we can stop processing. And finally, for each direction in directions without diagonals, we can just take the next point, see if the next point is valid, if it's within the bounds, and also if keypad next point y next point x is not equal to hashtag, because we cannot enter the hashtag area at all. So if we get there, we will enqueue the sequence plus the character that we need to press to actually get there. And that is, well, this is not correct, of course. We will have to cache sequence plus a, because when we get there, we need to also press the button. So we press the sequence itself plus the a button. Sure, the sequence is 2. Let's do it like this. So we will initialize these. So initialize this as initialize the array, the list. Then we either add an a only sequence. So that's gonna be just the string. Now, actually, we can move this to be here. So we just put a and continue. Or we will cache the sequence and then we will be adding to that list. So it's going to be sequence plus a. So that's the shortest sequence. And the same, now we have to also add the direction. So we need to find the right translation between the direction point to the arrow itself, the character. So direction character is going to be direction switch. And we will switch between these. So if you're going down in y coordinate, then we go down, right, up, left. So that's actually exactly what I wanted. And now we do plus equals directional character. That's good. So that's exactly what I need. We will be enqueuing like some additional things that are not useful, like we'll be returning to the start point. But as we're always gonna end at the shortest path length, and the map is just 4x3, it's very, very okay to just duplicate things and not care about it. It will not take any time at all. So this will cache us all the shortest sequences. So now we know what are the shortest ways to get between each pair of characters. And now we will read the codes, and we will have for each code in codes, we will be doing some kind of processing. So ulong result, or rather, it may be not necessary. This would be a huge, a small one. So it should be okay to just do int result. So we will do result equals plus equals. So find shortest sequence, or get shortest sequence for the code, and we will implement that method. And we will get the shortest sequence, get its length, and multiply it by the numeric representation of the code. So our numeric code equals int parse, and we need to take only the numeric characters from the input. So char digit. So we need to parse this thing plus also string join. So we'll take only the digits from the input. And what is the problem here? Code is it not working here? What am I missing? Using system link. So this is a, oh, wait. I see. Yeah, read all lines. That's the problem. So now we have is digit. It should be working. So the numeric code will multiply by the numeric code to get the result, and finally return result. Result to string. So that's this, and now implement the get shortest sequence. So get shortest sequence is string get shortest sequence for the code, and we actually need to do this in a kind of layers. So if we first start, we know that we need to enter a specific code on the numeric keypad. But to get it done, we have to move between individual numbers on the keypad using the directional keypad. So that's another layer, basically. And then another layer for the second robot, and that then for us. So we will have something like get shortest sequence for code in layer, and essentially we will be doing, well, actually we can just call it here with the layer number, starting with the 0 layer. That's our numeric keyboard. So keypad is going to be numeric keypad, and then we do the sequence. Sequence to string. So now for the code, we start initially on A button, that's in the description, and every time we press a key, we end up on A, so we always start from A. So for character index, for each character in code, we will be doing for each shortest paths between shortest sequences, subsequences, basically shortest subsequences. So we get the sequence from the character that we are on currently and the character that we need to get to. And I have to remember that I have to update the previous position, the previous character. Now the keypad, do we care about it anymore? We don't actually need to check that, right? We don't have to check that at all. So now to get the shortest sequence that is possible, we will do it recursively. So for each of those subsequences, we will try to see if we can create what is the shortest shortest subsequence that we can get from the upper layers this way. So we'll do get shortest sequence for subsequence on layer +1. So we want to get the sequence of presses that we are able to use for this specific transition from one character to another and pressing it. We want to see how we can get that sequence as shortly as possible from the upper layer. So best sequence solution and solution, and we should see if that solution is the best. So our current best solution will be initially 0, like null, and if current best solution is null or solution length is less than length of the current best solution, we store it. So finally, when we're done, we will add it to our solution sequence. So that's what we will. There will be building up the solution. And finally, when we're done with all of it, we end and return. And we need to stop the recursion. So when we get to layer to the top layer, like to our own keyboard, we just return the code that we are entering, because we just just type it immediately, basically. So if the layer is equal to 3, which is like the first layer is the numeric, second layer, zeroth layer is the numeric, first is the first robot, second is the second robot, then the third are directly us. So we do return the code. So because the shortest sequence to type that sequence is basically the sequence itself, because we just directly type it. So we don't, this is not the solution for that solution. The shortest way to enter that code is to enter that code directly. It will not expand anymore. So that is the shortest sequence. And now, that's actually it, maybe. That might be it. So let's see what happens if we run this against the test data and if it works out. So this result is not correct. So there is something off with our solution. Let's see if I get the result here. So if I press test data again, so 480 is, so let's actually see rather to see the actual numbers. So I will get the numeric code and I will get the shortest sequence for the code, and then get the length of it here. So it's easier to debug and see what happens. Okay, so this data. So the first shortest sequence is of length 674, which is definitely way too much. But the numeric code is even worse. So what is this number? Oh, I put it. Okay. That explains it. I put in my own input instead of the sample input. So let's try with the sample input first. So that's better. So with this data, should get 29. And shortest sequence is 68. Okay, so that's better. So this is the result. And it's still off a little bit. So what is the trouble here? So let's see which one doesn't run correctly. So the first one is 68, 60, 68, 16, and 68 it should be. Okay, the next one is 64 and 64. 64, 68 is the shortest one there. That is interesting. Why 68 for the third one? Actually, we can see the sequence there. This is what we have as the shortest sequence of length 68. Let's see what is the we put here our solution. This is the official solution. So this is okay, this is the same. This will end up the same. And where are we start to differ. So this one goes left, down, and A, and we go down, left, left, A. That is very weird. Somehow we're getting a longer solution there. Shortest sequence for code on the layer. Okay, so what's the problem? So if it's the same, we add A, then we do this. Seems like some kind of something here or something like that doesn't work correctly. Direction. So what is the problem? And okay, maybe we have to check here if length equals shortest path length. Maybe we add in shortest sequence that doesn't really match the data, but this shouldn't be still, it shouldn't use that number then. Directional keypad, shortest keypad. So can I accidentally overwrite some numbers? So it doesn't seem so. Like there should be, it should be always different. So what is the problem here? Something very minor, because the other inputs are okay. So it's only this one which is causing trouble. After a long debugging session, I finally found the mistake, and it's a very, very stupid one. Specifically here, this return statement is supposed to be a continue statement. So when I'm trying to find the shortest sequences, I was actually finding the first shortest sequence and then storing it and then ending by return. But instead I want to continue because I want to find all the shortest sequences, not just the only single one, the first one that I find. So this way I continue, I find all the sequences and then have them all so that I can go through them. I think the original solution actually just was finding one single sequence and all the entries in the dictionary was just one single entry. This is of course not correct, and the result is not going to work. So now with this data, I'm getting this value, which is actually the one that we are supposed to be seeing. So that's good. We have the full input. I will put it there, and we'll see what happens if we run it. So let's run the sample. Let's run the app again against the input file. This is the input file, and this is the result that we get, and hopefully it will be correct. And it is correct. Okay, so we have the first part finally solved. It was a struggle, big struggle. We'll see here the second part. So for the second part, we have, instead of 2 robots, we have 25 directional keypads that the robots are using, and 1 numeric keypad on the robot that is using the numeric keypad directly. So instead of 2, we have now 25. So 26th layer is now ours. So this should be 20. So let me start this. So it's gonna be part 2, and this is gonna be part 2 as well. So now the solution should be very similar, but we have now 26 layers, and that is probably a big problem because now the recursion will be much bigger, and to doing 26 to the power of 26, it's just not gonna work. Yes, so we immediately end up overflowing. So instead, what we have to do is make sure that we don't recurse when we actually already know the solution for that specific sub-problem. So I will be caching the results from this method and reusing them when needed. So shortest sequences, I will have dictionary of long shortest subsequences, and actually it will be a string of code and end of level. So now instead of storing the sequences themselves, we will store just their length, because that's the only thing that we actually care about. And the final string will be very long because it was already long for the 2 levels, and when we expand further, it's going to be just getting huge. So instead of getting the sequence itself, we'll have sequence length. This will be then long, because I expect a very large number. So length. If you're on layer 26, we just return length of the code. So long. And I want to also cache the results. So shortest subsequent lengths. So I will do for code layer, I will store the length there. And then we will also store the length here. So like here. So for this layer, code and layer, we will store the best there. And the best will now be ulong, because we just need the length. And this will be length as well. So this has to be length. So current best. And that is initially like ulong max value maybe. And we will be doing length. We will be checking if that is better than what we had before. So it's better, then we set it to length. And the length will then just increase the current, what we are building. Like this will be the whole length of the sequence, and it's going to be built up from the subsequences that we are working with. So this should be good. Now this will be this value, and this has to be also ulong. It's going to be a big number. And the numeric code, let's do it as a long as well. And now it should be okay. So hopefully with this addition, and actually to actually use this, so if subsequence, if we already have that cached result, then we return it. So we don't have to recalculate the same problem over and over again. With the test data, we're getting this huge number. Hard to say if it's correct because the test data, the description doesn't contain any description of the result that should be there. So I will try with the input file. And that is correct. Okay. This was a very problematic day for me. I spent way too much time debugging the very simple problem that I made during the breadth first search in the keypad. So that cost me a lot of time. But in the end, the problem wasn't that problematic after I figured that part out. But it was a hard one overall, especially like figuring out the logic of the solution. Writing the solution itself was just mostly straightforward, except for the mistakes I've done. The problem itself was complicated to figure out the solution beforehand. But yeah, that was a very cool and very complex problem to think about, because it involved recursion. So recursively thinking about the keypads and their function was kind of mind-boggling, I would say. So thank you for joining this longer session, but I will make another video to see if also ChatGPT can solve this. So stay tuned for that video. I will use ChatGPT 01 to see if it's able to resolve this. So thank you and see you later.